Hi guys, let's just do a quick review on significant figures. First we need to talk about why do we bother using significant figures. The first really important point is precision. The number of digits in any measurement gives us a good indication of how careful we were with our measurement, how exact we were and how precise. We want to make sure that we can express how precise a measurement was. It tells us how good your data is. So how careful were you taking that measurement, and how closely did you measure? Did you use an instrument that got you to the nearest foot or the nearest inch? Or I guess if I'm in science class, I should be using the metric system. So did I measure to the nearest meter or the nearest centimeter or the nearest millimeter? And so step one here is being able to count how many significant figures are present in a number or a measurement. So first thing to remember is any number that isn't 0 is automatically significant. So if we take a look here, every single one of those numbers is significant because none of those numbers is 0. So here we have 6, all of them, 6 digits that are significant. So every single one is significant. Any number between two numbers that aren't 0 is also significant. So this 0 right here, is significant because it is between numbers that are not 0. So here we have 4 significant figures. Now, any 0 before all of the non-zero numbers is not significant. Okay, so here we have a long list of numbers, and all of these zeros right here none of these zeros are significant because they're before the first non-zero number. Only these 3 digits right here are significant. So in this case, we have 3 significant figures. Now here's one that's a little bit more tricky. I threw in another 0. So none of these zeros are significant, again, because they are before the first non-zero number. This one is significant because it's between 2 non-zero numbers. So in this case, we have 4 significant figures. So again, with zeros after the last non-zero are only significant if you see a decimal point. So we have 4,500, 4500. In this case, those zeros at the end are not significant because there is no decimal point in any part of the number. So we would only have 2 significant figures in this top number right here. Now in the one below it, 45.00, there's the same digits, but in this case there's a decimal point. Because there is a decimal point, any 0 after the last non-zero number is significant. So here, all 4 digits are significant. We have 4 significant figures. Now we have 450.0. In this case, both of these zeros are significant. Both of the zeros in this number are significant. Both of those are because we have the zeros after the 2 non-zero numbers and there is a decimal point anywhere in this. So again, for here, we have 4 significant figures. So do some practice. You can pause now and do these practice problems, and when you unpause, I will show you the answers. If you take a look down below, right here, this is a great website you could go to that will give you practice counting significant figures. So please pause. Now we have to use significant figures in calculations. Again, why? Why do we have to bother doing this? Well, we want our answer to be exactly as precise as our least precise measurement. So if we take a look at this example down below, I started with a mass of 4.55 grams. I found another mass, a mass of 2.3 grams, and I added them together, and my total mass, if I added these together, would be 6.85 grams. The problem here is the mass of 2.3 grams is less precise than the mass of 4.55 grams. I must have used different scales to measure these masses. Remember, there's an uncertainty built into every measurement. So that 2.3 is just telling me that it's the closest to 2.3 grams. It could be all the way down to 2.26 grams, could be all the way up to 2.34 grams. I just don't know what exactly that mass is. And because this is less precise, my final answer cannot be any more precise than this one. So what I should do here is take 6.85. So what I should do here is take 6.85, and I need to make it. So what I need to do is make sure that my total mass answer is as precise as my least precise. So, and I'll teach you how to do that in just a second. Now if we take a look at a different kind of calculation, again talking about y, here to calculate the density of an object, we have a mass of 4.5 and a volume of 2.3. When you put this into your calculator, it'll spit out the density as 1.95652,174 grams per cubic centimeter. This is, if I saw this value given to me as the density of a substance, I would think that someone was very, very careful with their measurement. They were very careful, otherwise they couldn't have gotten the density all the way out to this decimal place, way here. But we didn't. We just had a mass of 4.5 and a volume of 2.3. Neither of those are particularly precise measurements. So our calculators don't know how precise we were, so we need to be able to round this so that it has the correct precision associated with it. So here are the rules for how to do that, and there's different rules for addition and subtraction. For addition and subtraction, you want to pay attention to the numbers after the decimal point. To what place is it, not the significant figures. Your answer should have the same number of digits after the decimal point as your measurement with the fewest. Let's do an example, or here are the steps to follow to get there. So step 1 is do the actual calculation, do the addition, do the subtraction. Then you need to round so that your answer has the same number of digits after the decimal point as the measurement with the fewest. Let's do a quick example. We have 7.650 plus 0.0006. I don't know. All right, so I'm going to put this into my calculator. I'm going to do 7.650 plus 0.0006, and I get 7.6506. Now, I know that this number here had only 3 numbers after the decimal point, and this one has 4. So because this one has 3 is smaller than 4, my answer can only have 3 numbers after the decimal point. So what I do is I look at that third number after the decimal point, because that's the number that I have to round. I look at the number next to it. That's a 6. If you see a 5 or above, you have to round up. So this number gets rounded to 7.651. For multiplication and division, the calculation rules are a little bit different. In this case, you do count significant figures. So here are your steps. Step 1 is do the actual calculation, put it into the calculator, do it on paper, and then you need to round so that the answer has the same number of significant figures as the measurement with the fewest. I know that density is mass divided by volume, so I will take 16.45 grams divided by 4.7 cubic centimeters. Put that in my calculator. And I get 3.5 grams per cubic centimeter. Now, this has 4 significant figures, this has 2. My answer is only allowed to have 2, and so looks like my answer does not need to be rounded at all because it already has 2 significant figures. If you want more practice problems, here's a website that you can use. So if you can pause in a second, you will see the answers. Thanks. All right. Bye, guys. Thanks.
Bye. Thanks.
Waffles. Charlie.
It's still going.
See you next time.
Adios. Amigos.
Peace out. Bye.
Hey.
Yay. Have fun time inside.
Yeah.
Miss Marie, can I have the sponge?